Hello, good day to you wherever you're listening from. Welcome to episode 003 of Smooth Dev Saturday. I hope you had a very good week. I did myself. I read a lot of code this past week and it was fun that I even almost forgot to do the stream. But hey, I hope your week was fun as mine was and it was productive for you. So welcome back. Episode 003 is here for Smooth Dev Saturday. Today is gonna be really interesting and longer than we've been having for the past 2 weeks. So get ready to dive in. Right. So a little bit of recap. Last episode we talked about application lifecycle management, where we talked about uh what takes place when you want to develop an application, when you want to write an app or a software solution, whatever name you call it. Where you first have the envisioning stage, then you have the requirement gathering phase, application design phase where the architect comes in, and then you have the development phase, the testing phase, the deployment phase, and then maintenance phase, and then this goes on in loops. And I said it could either span through as a monolithic structure of the whole application, or this could go iteratively in the different components that make up the whole solution. A team might be going through this in multiple sprints. For example, when I mentioned making a car, where you could have a team making the door go iteratively, a team making the tires going iteratively, a team making the engines going iteratively, and then bringing it all together in one very large space. So that's what we talked about last week. And in case you missed it, you might want to check. I think it's on YouTube. You can check youtube.com/Dara Oladapo to get the recording of that session. So basically it's time to get started into episode 033 rather, where we'll talk about core programming concepts. And as I said, this week will be longer than last week, so get ready. Well, not be that too long so that I bore you out, but of course it will be like, I don't know. Let's get started. Until we get started, we wouldn't know. Right. So we'll be dealing with core programming concepts. And of course, this part of the fundamental series. So basically, let's dive in. Not much of ado. So this is what we're talking about. In this episode, five main things here. The five. We're talking about storage and processing, data structures, algorithm, decision making, and repetition. Yeah. So I wouldn't want to dive in right now until I get to the main topics. I will explain the concept and then hopefully I'll show some demos. But let's get started with the first item, which is storage and processing. Um, Computers, our motherboards, the electric components, where it's either on and off. And these are the things the computer understand basically. But when we write our codes, we write them in some high level language like C Sharp, Java, Objective C, Python, Ruby, Basic, all those very impressive languages. But at the root of everything, these things go into binary. So we have a compiler in the middle of our programming language and the machine. So the compiler actually takes our code, that's the English like structure of representing instructions, and then compiles it into what the machine can understand, because basically on the circuit you see that on and off. That's what makes the things happen. In the early days of programming, where people have to use punch cards, so there are a bunch of punch cards people slot into slots to make them work, but it's not so these days. It's grown more advanced, where you write code in some English like languages, at least not as boring as assembly language these days. But those guys that really wrote those languages, I salute them. So you write language like C sharp, you say for each console, write like this. It looks English like, but in essence, this goes into processing. And in essence, when you execute programs, these programs are run from the memory of the computer. Memory now, I mean the RAM of the system. So when you run a program, it's loaded into memory and then it's run. So that's why you see, and of course, memory is expensive. Comparative, let me compare that to long-term storage. For example, if you want to buy 120 gig HDD, for example, that will be way cheaper than buying a 128 gig SSD, because SSD is way faster. It uses electric silicon chips, and then that even SSDs, a 128 gig SSD is way cheaper compared to a 128 gig RAM. That's the memory slot that goes into the system where the program is loaded onto. So memories are pretty expensive. So there's a limitation to the amount of programs you can run. That's why you see on some laptops or computers, when you run things that are going sort of above the limit of what the RAM can take, the system starts dragging, trying to shuffle in between, trying to close down some idle tasks, shuffling to keep that running program a priority. So that's why most times you advise to use a RAM that is good enough. That's why there are some recommended specs for some operating systems to be able to run on your computers. So that's that about storage. And of course, these values, so the picture you see on the slide is the ASCII table that contains the characters and the ASCII values for them. I just had to put that out there. It's not like I'm doing something too much with it. Okay, but of course you don't have to know these things, this concept of storage and processing in there. But of course, if you know it, you're a better programmer for it. That's why I had to put it here. So I'll get started with the main crux of this matter now. So we'll start with variables, constants, and data types. So the first item, which is a variable is basically a name storage location that we refer to in code. So for example, you say let A represent a dog. Remember when we used to do mathematics, elementary mathematics? I went to primary school. I don't know what they call it in other parts of the world. So in my primary school, they say let A represent. So they'll be like, are there S2 apples? They gave Bala 5 mangoes. How many apples does Bala have? Something like that. So you say let A represent the amount of apple Bala have. That A is a variable. So what it means is, for example, take a person. When I meet a person, the person has attributes: the face color, the color of the skin, the color of the eye, the shape of the head. I recognize the person, yeah. But of course, if I want to call the person, I won't say, "Hey, red hair, black face, black hair, come here." That would be way too long to call the attention of the person. But of course, this person has a name that can be used to identify all the properties the person has. So when I say, hey Dara, Dara is a guy that most times wears glasses, is on this type of haircut, almost always a headset, except when it's not listening to something. And I have the attributes. So when you call Dara, or when you see me, you identify me. So that Dara is sort of like a variable that is pointing to a location in your brain where you store my attributes. For example, when you see me, you know this is me. So, but you won't say, I met this guy yesterday, his name is Dara. But when you want to describe Dara, now when you call Dara, you now start bringing out the attributes that make up Dara. So that is basically what the variable is to a computer. And then of course we have a constant. So when you're writing code, for example, we have constants in mathematics. So for example, pi is a value 22/7. So it is. So in most cases 3.14, 3.142, and it goes on and on, depending on the level of precision you want to go. But having to write 3.14 over and over again when calculating area of circle or perimeter of the circle in your code will be strenuous. So when you come back to the code, you'll be like, when did I write this? What is 3.14? What does it mean? But when you declare it, so a constant basically it's a value that is created at the start of the execution of the program. So when the program executes, the constant is loaded up, and you would not be able to change it until you recompile the code. So that is basically what the constant. And of course, we have two types of constants. We have the constant value and the literal constant. What the literal constant is, there are values that can be changed. Values like 1, A, 2, 3. But what can happen is there's a constant value whereby you are, when you load it in a memory, you assign the literal constant to a constant value. For example, pi is, in this case, A. Pi is 2. A is 5. So that is a constant value, assigning a literal constant to it. So a constant basically loads at program execution, and you're unable to change the value unless you recompile the code. So that helps you to be able to at least you have a name reference for, so you can easily call it on and off as you wish to do, instead of having to remember the value of it, because the numbers might be large to remember. And also, getting to data types. Data types are basically just numbers, characters, and special types. Now, special types are what I'll deal with when I get much later into this series. But they are basic data types that you deal with in programming, and this will be represented in many ways depending on the kind of language, programming language you write. For example, there's bytes, char. So a byte is basically between 0 and 255. Sort of byte is IP address ranges. So you have the maximum is 255.255.255.255. That you can have an IPv4. So yeah, so that sort of thing. Then you have char, which is a single character. Like, you remember when I showed us the ASCII table. So sort of this A, B, C, D, all this stuff, they are characters. All this, let me see if I can annotate this pen. All this where is it? So all this stuff here, there's the green, pardon me, all this stuff here, they are characters. All this stuff around here, they are characters. All this stuff, they are characters. Okay, then let me just go back to where I am. Then of course we have short. What a short is simply a signed integer which has a very small value. Then of course an integer is a larger portion of that. So we have so in C-sharp representation, a short is int 16. Is it? Yeah, int 16. Then an int, a regular int is int 32. Then a long is a longer version of integer. So they are signed integer values that are very long. So it can contain, I'm not sure, 9 something something. I don't even know the value, but of course you can use your favorite search engine to get what that value is. And of course there's float, double, string. So strings are a combination of different characters. Then we have boolean, which signifies true or false. I don't want to delve into this much about, because of course I'll start talking about programming languages, which I really don't want to talk about in this section of today. But of course I'll write some language after. Please note, I'll be sure all my demos, well, most of it anyways, will be in C sharp, because I write C sharp basically. Of course I can write some other language, but C sharp is my favorite. So I'll write in C sharp, but regardless of what I'm writing, you can apply this knowledge in any programming language you decide to choose to write. Okay, so just putting it out there. I'll be writing C sharp, but you can decide any programming language you want to use to be able to understand it. And of course, the code samples are available on GitHub. Let me see if I can grab that link for you. So I think it's at github.com/Dara. Wrong URL address. Yeah, that will not be found. Dara Oladapo. So you should be able to find. So if you go to my GitHub address, I'm not totally sure where I put that now, but let me go to my repositories and I will be able to find that code. I'm just showing you this ahead, so maybe you want to follow along. Okay, this is it. Core programming concepts. So I have stuff I've done around data structures, decision making, and repetitions. I just pushed this code like few minutes ago. So yep. So I'll be coming back to that much later. Okay. So let's continue. Now, talking about data structures. Of course, I won't be going way in depth in this. But I'll just touch on this things on the surface. If you want to know more, of course, you can get some more advanced books or videos to go through this topic. And of course, if you want me to go more in depth into it, maybe you can make a request. I would find time to slot it into the show. All right. So we'll start with arrays, then we'll go to stack, skills, and dictionaries. I will not define it here until I get to what they do really basically. So let's start with arrays. Now, talking about arrays is simply a collection of similar data types that are accessed by their index. So let's say, for example, I usually make this as an example when I'm teaching C sharp. So, for example, my father gave back to three boys. Three boys, we all boys. So, I'm the last born. So we are three. And so we have my dad, my mom, and the three of us. And then, when we pray in the family, we have this clap code that my father does. So when it's time for my mother to pray, he does. When it's time for me to pray, he does, because I'm number five in the family. That is sort of what an array is. Of course, he is. And then my eldest brother is, my elder brother immediate is. So that clap is is an index for each of us, each of our positions in the family. And of course, at some point in time, our cousin came to live with us, and then there's the older one and the younger one, so we became seven. Then the elder one became, that is six. So that is his own index to get out the value from him. So that is sort of the way arrays are. So what happens is, if you go to the first index, you get my dad. If you get my mom, you get my eldest brother, you get my immediate elder brother, and then you get me. So that is my index in the array. And of course, it's just like that. And please note that in some programming languages like Python, arrays their indexes start from one. But the most modern programming languages like Java, C Sharp, I don't know, maybe JavaScript. I don't write JavaScript that much to know. So their indexes start at 0. So if you call elements at index value of 0, you'll get item 1. And of course, I'll show this, of course, when we get to the demos. I've written them already, and I'll show us. So that is that section about arrays. Of course, that's all. I'll talk about it now. If you want to know more, of course, you can search the news. But that is the concept. And of course, note that you can either have an array of simple types or complex types. I will explain more about complex types, I think, next week when we're going to object-oriented programming concepts. But let's jump the bell. Let's just move on. So we have another concept in data structures that are called stack. What a stack is simply a collection of objects that are accessed by a push and pop. So what is push and pop? Let's not get there yet. So for example, you have a stack of waste bins. What happens is, if you need to get to the last item, you first have to remove all the items on top. Or you have a rack of plates, you want to get to the plate at the bottom, you have to first remove all the stuff on top. So the process of removing is called popping, and the process of adding on top of the stack is called pushing. So one of the things I say about this is, in stack, because I write mobile apps, some of the navigation is push. So when you push, you add in more navigation pages, and when you pop, you're removing the navigation pages from the stack. And of course, this happens at operating system level, on some compiler level. And of course, I will explain this a little bit when we get deeper into the concepts. So that is the concept of a push, adding to the stack, and popping. So it works on the concept of last in first out, or first in last out. So the first item that gets into the stack will be the last item to come out, and the last item that you put in will be the first to come out once you start popping. Okay, you get that concept now. So let's go to the next concept, which is queue. Now, a queue is a collection of objects that are accessed by queuing and dequeuing. So what happens is, it's just like an assembly line, where, for example, you are in a line to, I don't know now. Okay, you are in line maybe to, on the registration queue, for example. Why am I using queue many times? I don't know. So you're in a registration queue. The first person to get to the registration queue, and of course, except there's some piracy stuff happening, is the first person to get in there is the first person that will be attended to, followed by the next person, then the next person, then the next person. So that is the concept of a queue. And the major keywords. So if you're adding to the queue, it's called either queuing, or you can call it enqueue. Queuing or enqueuing, anyone, whichever one works. That's why you have that in bracket or parentheses. Then dequeuing is the process of removing from the queue. That means getting the least recent item out, and queue is pushing the most recent item in. Okay, so that is that about a queue. Then when we get to a dictionary, so a dictionary is simply, the dictionary, the English dictionary or whatever dictionary you've been used to. If you need to know the meaning of a word, you go to where the word is in the dictionary. So the word that you're looking for is the key, and the meaning that you get out of it is the value. So a dictionary is simply a key value pair scenario where you have the key, the word you're looking for, the key, what you use to access the value. Simply that is what it is. So you can have, and they can be of different sort of data types, of course. So if you want to access the value, you want to access them by the keys. So if you want to get item 2 in this table, for example, you need to access it via key 2. Just like when you enter your house, you need a key to enter the house. That is the concept of a dictionary. So the key and the door, the sort of dictionary in that concept. I'm sorry if the example is way out of line. So not to waste much of your time, let me show you the demos, and then we of what's it called now, of data structures. Then we'll move on to the next concept called algorithms. So let me just get Visual Studio 2019 open here. Data structures. Yeah. So the code I have up in here, let me do a little bit of zooming. I hope you can see. I'm sorry, I'm using dark theme. Let me try to move to light theme. I'm used to using dark theme all along. So environment color themes. Let me just change it to light so you can see better. Or let me just change it to blue. Oh god, I'm gonna hurt my eyes right now. Excuse me, I need to drink water. Glad that happens. Okay, I hope that is better now. Okay, so this is what happens. Forget all this stuff at the top, all this programming C# jargon on the top. If this were a C# course, I would have explained it. But the concept is still the same across all programming languages. So I said the array is, so this is an array of string. Remember I said that an array is a collection of the same data types, objects of the same data type. So this is an array of string, and I called it my string array. You will have different ways of naming variables in whatever programming language you decide to write. So this is how we do it in C#. One of the ways, of course, there are other ways of doing this. So what happens is I initialize this variable called my string array, and immediately as I assign it, I am putting in the values in there. So I assigned item 1, item 2, item 3, 4, 5, up to item 10 in here. Don't ask me I'm using 10 values, I just feel like. Okay, so what I'm doing now is, after I have initialized and added items to the array, what I'm doing is I now want to access the item at index 2. Remember when I was talking about arrays, I said the indexes in language like C# start from 0. So this will be 0, this will be 1, this will be 2. So if I say, when this program executes, the value that will be printed here, let me modify this. The value that will be printed here should be this, because it is the third item. So basically the value is the item at the value you print, you're trying to get -1 ish. So if you're looking for the third item, it's at index 2. The 10th item is at index 9. You get a gist now. So then, as I mentioned, don't mind all this syntax of C#. So what I'm saying now is, let me see the solution is got for me. Not that. So what I'm saying now is the console should output the item that has index 2, index value 2, right? Then it will output that, but I don't want to burst too much. Let me see if I can run this in the integrated console, in the package manager console of Visual Studio, instead of having to run in a very separate console. So let me just put this up. Let me try to get the directory for this. So let me go to array. Okay. So let me just do a .NET run. So what happens now is that it's compiling and it should run any moment from now. Or am I waiting for something? Nope. Aha. So that's it. So when I did a .NET run, it went ahead to compile the application. So what I'm saying is the item at index, something happened here. Let me see. Nope. Huh. Okay, I'm not sure I saved it. I think that is why that was happening. So let me run that again, because this was supposed to come out. But don't worry about that. Anyways, just I'm sort of a perfectionist when it comes to this kind of thing. So the item at index 2, as I mentioned, will be item 3, the third item in the array, and that is what is outputted for us here. Then the next item is the next line of code. The next instruction says it should print out the total length of the array. That means the number of elements it contains. So I'm saying my string array contains 10 elements. But what I should actually do is move this to the top to show it in order. All right. So I think this is cleaner now. Then I say, now if I want to print out all the elements of the array, I'm saying I'm using a for each loop here, and even though I won't touch for loop in this video, it's just a kind of repetitive step that happens. So I'm saying for each var. Now var, let me touch on that. When I mention variables, var is more like a generic data type that whatever data type the value you're assigning to it takes is what it will conform to. So just be careful when using var. There are sometimes where you can just use the explicit data type. This is called the implicit data type. Of course, you see the suggestion here that is telling me to use the explicit data type instead of var. So if I do this, it will turn into a string for me, but let me just keep it as a var. All right, so it print out all the elements in my string array out for me. So that's basically it. So let me now go to show you the next item will be stack, right? So let me go to stack and let me do a dot. No, don't let me run it yet. Let me just go ahead to show you the code. So this is stack. So I mentioned the first item to get in is the last item to come out. And I mentioned that the process of adding items is called pushing. The process of removing is called popping. Just like a pop of champagne. The stuff at the top come out first before everything at the bottom. Just kidding about that, but it's true. Okay, so I added all the items. I pushed all the items in from item 1 to 10. And I'm telling this to output the total count of the items in my string stack. So I'm outputting everything. So of course the count, not everything now. Then I just put a new line here. And I'm saying, now I'll explain this much better when we get to repetitive steps. So I'm saying, while my string counts, while the items is the total number of items on the stack is greater than 0, that means it contains at least one item or element or whatever name you want to call it. This loop should go on. Then what it does is, I'm saying, remember this var, the implicit data type, the pop item, the item I want to pop is the item at the top of the stack. Then I say console the right line, this pop item will now been popped off the stack. Then I output the new count, the new total number of items that are in the stack. And then this goes on until the loop finishes. So remember I said that was an implicit data type. If I want to make it explicit, I think it should be it's object. Because of course it is not so sure even at that point what item it is, because it's just a stack. And I think that's it. So you can use var object, whichever way you choose to. So let me decide to go ahead and now run this. So I'll just do a .NET run. Of course, I could have done this here, but I have too many stuff running. So I want to be sure what I'm running. So, So the first thing that happens is that, let me see if I can pop this off to the side. Oh, hold on. So I wanna bring it side by side. Now I'm not sure where that went to, but let me see if I can bring it back up. I found it. So let me float this specific one. Float. Yeah, it's just the one I want to float, and I snap it to the side this way. Oh, I'm not sure if this is better, but I think it is in my opinion. So we could see stuff running side by side. Let me just resize this a little bit. Okay, let me do a little bit more. Okay. So this is what happens. When I did a run, it first outputted for me my initial stack count. And that is 10 because I have pushed in 10 items into the stack. I printed out the count, and then while the count is greater than 0, while there's at least one item in the stack, it should start popping off and telling me the new count. So item 10 was popped off. That was the last item that was in. So let me do a little bit of stuff here. Let me do this. Let me put the breakpoint here and let me run this again. So the breakpoint is simply sort of the thing we do when you're debugging to inspect some things or maybe solve some problems in code. Oh, that did not happen because I was not actually debugging. So let me set I'll have to do something here. Stack example as my startup project and run. Sorry about that. So it's launching my debug console now. So what happens is when it gets to the place where it's supposed to go to the next item, it should break execution. So stuff is still running. Okay, it should come up any moment from now. So as you can see, item 10, which is the last item that came in, has been popped off, and the new count is now 9. The second to the last item will be next in line, right? So let us actually go ahead and continue the execution of this program. And you see that item 9, that was the second to the last item to get under the stack, has been popped off. So that is the concept of how it happens, and this goes on and on and on until the program finishes executing. Okay, so that is the concept of stack. I'm showing that in code, but let me return to normalcy here. Okay, so that's the concept. So let me go ahead now and close this debug window. So that is the concept of a stack. So let me go ahead now and go to queues. Okay, so the concept of queue. I remember I said in queues you enqueue and dequeue. And so I'm going to queues now. So before I run, let me say that, so I declared the new queue, I initialized it. You can do this whichever way your programming languages do this. So what I did was I enqueued from item 1 to 10. Remember I mentioned that in a queue, the first item to get in is the first item to get out. So when I do the enqueuing, as I'm doing the dequeue, item 1 will be the first item to get out. Then it will go to item 2, 3, 4 till it gets to item 10. Then what now happens in my code is I'm saying the initial count is 10, and I'm saying that the first item to get out of the queue will be, so it has another method called pick. So pick allows me to have a look into what the item that is next to come out is. So that's what a pick does. So what I'm now doing here on this line is to say that I'm just saying key value, that's a variable now. So I'm dequeuing and assigning that to a variable so that I want to save it so that I can print it out later as I did on this line. So I printed that out, and then I'm saying I'm now outputting the new queue count, and I'm saying the next item that will be up for dequeuing is this. Of course, I didn't do a for loop around this just because I didn't want to waste my time. I've already done that in the first one. So what I'm going to do here is do a .NET run again, and the program will execute. So that is running. Permit me to drink water again. Yeah, so basically that is what happened. As I said, the first item 1, to get out of queue. And I said it when it dequeued, item 1. Then the next item when I did a pick to look at what will happen is item 2. So that is the concept of a queue in programming. Of course, you might not get to use this much every day, but of course, if you're going to the process of writing compilers or operating systems or some advanced level stuff, or writing your own, yeah. So there are cases where you get to use it basically when you get advanced, but maybe you don't get to encounter it. But of course, it's nice to know this concept because this is what forms the basis of programming. And of course, this is just fundamentals. There are more advanced concepts like linked lists, all those kind of things, and how they're implemented. So that is that about queues. The next item now would be that would be, what is that? Oh, dictionary. Yep. So do not mind this. So a dictionary, I said it's a key value pair, right? So what I'm saying is I'm declaring a dictionary of string. The key is a string and the value is also a string. Right. So what I'm doing now is I'm saying add to my dictionary Q1 and item 1. Or should we make this fun? Let me change this up a little bit. So let's say I want to reference this as the 3 people my father gave birth to, right? Okay, now I'm gonna share their names. Keep this a secret between just me and you, right? Keep this secret. So I'm saying the key for this is firstborn, right? And I'm saying the name, the value I want to keep here is Olusegun Oladapo, right? That is the key I want to use to access him. So when they say firstborn, the key is firstborn and then it gets Olusegun Oladapo. Then when I'm saying secondborn, that is Israel Oladapo. Getting that now? Then when I say, well, thirdborn or lastborn, I just prefer lastborn. Thirdborn is just heck. So then this is where you find me. Let's do some more fun. I can now say, let me just do some copy and pasting here, okay? Just pardon me to do this now. So I'm calling this daddy, and I'm saying mommy. I'm not gonna give you their full names, so I'm just gonna say this. Let me just cancel this and say, yeah, this is better. All right, so if I call the key daddy, I get E Oladapo. If I call the key second born, I get this. If I call the key mommy, I get this. Okay, so dictionary. So I'm getting the total count of the item. So item that has key. Let me change this now. Key daddy. So I try to get item in daddy. So key 4, 1, 2, 3, 4. No, nobody removed from my family. So let me just cancel this out. So the concept of removing is actually to remove an item from the, what's it called now? From the dictionary. So let me just delete this. Right. So let me run this now. Let me see where I'm at. Okay. So let me go to dictionary. So the key is daddy, or this, or this, or this, or this. Then these are the values inside it, right? So let me just switch this up a little bit. So the fun thing about being a programmer basically is you can do and undo as you wish. That's what makes programming fun for me. So I was just having fun on my own here, of course, passing knowledge. So I'll say uh daddy's name is okay. Let me see if that actually works before I go ahead. Okay, daddy's name is E Oladapo. That works. So let me just so that's the concept of dictionary. So if I change this now to say firstborn, and I change this again now to firstborn, all right, then I run this again, I'm gonna get another value which will be referencing this. So you look now and you should see this value come up in the console. Oh, I should actually make this larger now. So that is this right there, just as we keyed it in. It's how it's so that is the concept of a dictionary. I hope you understand the concept, and I just try like to make this personal so I can pass the knowledge more. I'm sorry if you don't quite like it. Right. So that is that about data structures in this section. So what I'm gonna do now is go to the next item, which is algorithms. Now, I'm not gonna do any demo for this, so I'm just gonna say it. Algorithm is simply a process of doing things. It's the way you think about solving a problem. You want to write an app that adds A and B. What is the process you go through? You wake up in the morning. What are the processes you go through before you go out? You want to cook. What is the process of making it? Now, there might be many ways of achieving it, of course. For example, I cook sometimes. So there's a kind of food I like to eat. My house knows that also. So when there are two ways, there's the way I knew before I met her, and there's the way she knew before she met me. So I try to mix those two ways and see which one is optimal. Of course, I do both. Whichever one comes my head now. So one way that I do it is I boil the water first. That she does it, boil the water first and add in the items to cook. One way I do it is I put all the items from the start. But it still ends up in the same result, but one is more optimal than the other. Or maybe they have the same optimality. So that's the concept of algorithms. They might have the same optimal results, they might have the same sort of optimism, if there's such concept in programming, and one might be less optimal than the other. But of course, they achieve the same result. For example, one popular algorithm is the bubble sort algorithm in programming, where you swap values. So you have a list of numbers, for example, 10, 9, 8, let's say just 5 items. Then you want to arrange them in ascending order. What happens is it compares the first and second value at first. If the first value is greater than the second value, it swaps their position. Then it goes ahead and do that for all the items in the uh, in the in the list, in the collection. Now, what if the smallest number is at the end of the collection? Now you have to go through the n times that exists. So bubble sort is not very optimal in that sense, but it does the job, of course. But it's not optimal either. It takes too much space or too much time. So when you get to space and time complexities, you will understand that. So it either takes too much space or too much time, or maybe too much of both. Then there are more advanced ones like binary search, depth first search, all those sort of algorithms. Now, these are step-by-step ways. Basically, that's what our algorithm is. A way of solving problems. It could be optimal or not. Get it? I know you did. So the next concept is decision making. One thing, so because I'm more of a night person, even though these days I've tried to cut that down a lot, so I try to sleep at night. But in the beginnings of my programming, so I check my timetable. Do I have class tomorrow? Do I have something important to do in the morning? Then if I do, then I'll make sure to set an alarm for the next day. Remember, see the word I use there. If I have an important thing to do in the morning, I set an alarm so I don't wake up late. Or I may decide to not put an all-nighter if I have a very important thing to do in the morning. And in some cases, if I have an important thing to do in the morning, and I've already put some all-nighter and I try to sleep at 3, I'll probably wake up very late too. I don't sleep at all. So these are things we do every day. We make decisions based on some conditions. Yeah. So the same thing applies in programming, and it is one of the fundamental concepts in programming. So you make decisions. If a variable is this, do that. If it's not this, do some other things. And there are some major types of decision making formats. We have the if else, and if else if. Then we have the switch as the next case. So what I'll do to not talk too much about it is actually go into the code and show us what that does. So let me go to the using if section now. So let me just go ahead and close data structures. I'll remember to push that once I'm done, so you can have the updated code. Now, what happens here is, let me open the package manager console again. So I'll put this at the bottom this time because I don't want to mess up my brain. Right. Okay. So what I'm saying is enter a number. So what I'm actually trying to have some fun here, I'm accepting an input. Then I want to say it's very simple to write an if condition. If it's this, so it comes in the format of if, then in C# you have a bracket, parenthesis. If you have condition in parenthesis, if that is true, then you have a block or one liner that says do this, right? So if I go ahead and run this, so I'll say go into using if, then I'll do a run. So let me just go ahead and compile that. I'm still okay. So let me enter a number. Let me say 5. Something going on there, I don't know. I'm not sure what is going on here. I'm trying to input a number, but it's not working. Let me just stop that and run it again. For some reason, I shouldn't be doing this again then. I should be actually be using this. So let me just go ahead and run this normally. And what I'll do, so you see this, I'm executing anyways here. So this stuff doesn't run away. I'm gonna start this in node debug mode. So this executes whichever condition is made anyways. So I will go ahead and start without debugging. Right. So it should run now. Pardon my computer, I've been doing a lot of work all week. Something's going on that I don't understand. Okay, I should stop running this. Okay, so I should enter a number. I put in 5. Let me zoom into that for you. Yeah, I don't press some wrong buttons tonight, okay? What am I doing here? I'm zooming the wrong way. Aha, it's working now. So when I enter 5, it's saying I'm executing because 5 is greater than 2. And that is the exact instruction I have in here. So I'm executing because I'm greater than 2, because the value I put in is greater than 2. And this executed anyways. But of course, if the value were to be lower, or let me uncomment both of them. What did I do here? Okay, now let me run this again. So if I were to output a value lesser than 2, let's say 1, for example. Let me zoom in. Okay. So let me say 1. Okay, it's executing because 1 is lesser than 2. That is what happened right in there. Okay, so that is the concept of if condition. So I'll just go ahead and comment this out again. Then there's the concept of if else. So what happens is if the value is lesser than 2, it goes ahead to execute this. But if that is not the case, maybe it's equal to 2 or greater than 2, it goes ahead and execute the statement. So to actually watch that, let us set a breakpoint on each of these beginnings. All right, and let's run. So again, I'll input 1. So if it reaches 1, it should get the program should break at this point. If it's greater than 2, it should greater than or equal to 2, it will break at this point. So let me go ahead and input. Let's do 5, right? Let's do 5. That is still running. This PC has done a lot of work. Okay. Okay. I'm expecting something to pop up here. Let me run this again. I'm not sure what is going on here. Aha. So let me input 5 again. Okay, you see, because I inputted 5, you see that 5 is not less than 2. You see what happened in here? Let me zoom in. You can see that. Let me use the normal magnifier. So you see, my value is lesser than 2 is false. If I mouse over this, nothing happened. What am I doing? Okay. Then it means if this is not true, if it's not false, it has to be true because it's either true or false. It goes to this line and executes. So that is what happened just in here. So if I go ahead to continue, it outputs. Okay. I'm not sure why that outputted twice. Oh, I have another thing at the top. So I was supposed to actually comment that out. So I was supposed to comment it out. So that is the concept of an if-else. Then an if-else-if is a three-way thing. So you can have multiple if-else-ifs, else-ifs, else-ifs, as much as you wish. But instead of having that, there's a better way, which is the next item I'm going to. So now if my value is lesser than 2, print this out. And if it's exactly 2, just like a lottery, you won the lottery ticket, congratulations, okay? And then if it's greater than 2, bam, just moves on. Right. So let's do this. Let's just keep doing this, all right? So what I will do now is I will input 7. So it reaches I'm executing anyways. Okay, I should do a console.readline here. Don't mind what I'm writing here. It's just so the program doesn't run away. Okay, so let's do this again. So I inputted 7 the other time. Okay, now I inputted 7. You see, it's existing because 7 is greater than 2. All right. So if I execute this again and I input 1 or anything lesser than 2, let me even try -8. -8 is lesser than 2. Okay. But if I were to input 2, it would win the lottery ticket. So that is what will happen right in here. You see, we win. So that is what happens in if-else-if statement. So I will go ahead and comment this out now and uncomment the first if item just for demo purpose. Right. So remember I mentioned that instead of if you had multiple items, so for example an enumeration. Now I don't want to make this too complex, right? So what I want to do is let me just create an enumeration. For example, customer feedback. How did you read today? Good, poor, bad, awesome, horrible. So let me call this feedback. All right. And please don't worry about this complex stuff I'm doing. I just want to show the concept of switch. Okay. So let me just make this public and change this to enum. Oh, pardon me, I wrote public. So I want to say what are the ratings? Excellent. So excellent. So let's start from the smallest. That is very bad. No, I like starting my enums from 1. Don't worry about this section, of course. Moderate, good, and very good. All right. So what I want to do now is call this. Do not worry about. Okay. Enter a number for feedback. So between 1 and 5. where 1 is very poor, very bad, and 5 is excellent. All right. So let me change the sample code I have written here. Okay. So I'm gonna do a switch. So what am I switching? I'm switching. Okay. So let me actually rename this. Let me clean this up. Sorry about the mess up. So the user feedback is, so I'm gonna do what we call a casting here of my value. I hope I'm right. Okay, I think I am. So I'm gonna switch the user feedback. All right, don't worry about how these things came up automatically. So if the rating is very bad, so I'm gonna say a right line of we are very sorry, we'll do better next time. Let me just repeat this step here. Let me say, what can we do better? If, of course, I'm not going to continue the execution of this. So what can we do better? I'll say, thanks for your feedback. We wish to see you again. Okay, then the next thing is oh, sorry. So phew. Thank you. We look forward to serving you next time. Right. So, and of course, what happens in default is if none of these cases are met, if none of these conditions are met, so we'll say input value out of range. I just wish the program doesn't crash if I do something weird here. Okay. So at the end there, I'll try to put the console.readline, so the execution doesn't just run away. Okay. So let's run this. Switch here. That's where we are. Okay, that is running. Okay, so let's go excellent. Yep, let's go excellent. 5. You see, when we go for excellent, it switches this case. So if you were to have at least more than 2 conditions, you should consider using it because it's way easier to manage that way. And of course, you can have falling switches where you can match the conditions. But this is not a concept that we would like to treat today. All right. So I will stop executing this and I will try to input something not excellent and something out of the range of 1 to 5. Okay, so let me run this. Sorry, I'm trying to respond to my wife. Okay, so let me enter, say 2. So we are very sorry, we will do better next time. That is bad, right? So let's run this again. And let's input something weird. Let's say, for example, 7 or 10. Right, so waiting for that to come up. I'm not sure why this is not coming up. So let me just stop that and run it again. Okay. Come on now. Uh, uh, Come on. I do not know what is going on. So let me just make it stop for a while. Run it again. This thing's happen. I don't know why. Aha. So let's input a 7. You see? Because none of these cases were met. Let me do a little bit of zoom into that. Because none of these cases were met, it said index values out of range. Input values out of range. So what happened now is, because it couldn't meet any of these conditions, very bad, bad, moderate, good, or very good, it defaulted to this. So this is like the last if. If nothing happens, still back by my law. Pardon me for speaking Yoruba. Okay, so that is it. That is the concept of switch making decisions in programming. So the next concept we're going to now is I think repetitions, and we'll have a little bit of fun here. Don't worry, it won't take too much of your time anymore. So talking about repetitions, you do things over and over again, and these things, of course, they are the things the computer is good at, to do things over and over again without maybe getting tired or frustrated or shouting in your face, right? They have to do it again. So there are ways to make this happen in programming, and these are the basic. I jumped that. You did not see that, okay? So I wanted to actually show the demo. Go to Visual Studio. So yeah, this is Visual Studio. You did not see what you just saw. So I'll start with a for loop. Yep. So it's pretty simple. What the for loop does is it has what we call the initializer, the start, and then the termination, and then the incremental, or whatever you want to go by, whatever name you want to call it, that's what I call it. So what happens is it starts at 1 and ends at 10. So as long as the value, so what happens is it first starts at 1, then it outputs this value, then as long as it increments, so it goes get this value, print it out, increment or decrease as the case may be. Then once it finishes execution and reaches here, as long as the value is less than meets the condition in here, it prints out, increments, go again, prints out, increments, and go again until this condition is out of scope. So let's run that and see how that happens. So this should print out for us 1 to 10. Okay, and then please run, please run, please run. Please run. Yep. So you see, counter is at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Just like that. That's the concept of a for loop. So the next one is a while loop. So what a while loop is simply, so what you see what we did here is to have an incremental value in here, the conditions for that. But what the while loop does is it checks the condition and executes. So while that condition is true, it keeps executing. So you have to do something with that incremental. So what happens in here is to print 1 to 10 here, I hold on. Yeah, I print out and then I increment, then I go over this loop again. As long as this condition is met, it keeps executing this. So sometimes when you write in code, there's something called an infinite loop that goes just on forever until something bad happens and it backs up. So be careful when you're doing your loops and check very well to make sure you don't run into an infinite loop. So for example, if I were to remove this, let me just show an infinite loop first. Please pray I get out of it, okay? So let me change the startup program to a while loop and run it. Excuse me. I should actually collapse that view. Okay, you see? It just keeps going on and on and on and on. Oh, just in case you don't see it very clearly. So let me magnify. So this keeps going. It just keeps going on and on. So that's an infinite loop, just like that. But thank God I'm not out of memory yet. So I'm gonna terminate that and bring my incremental back. Okay, so putting that incremental will make sure the loop stops when it reaches 10. Yep. So once it reaches 10, it will terminate. So just wait for that to happen and you see, boom, it stopped at 10. Because it has met this condition, that means this loop had to stop. So the next concept now will be the do while loop. Yeah, there are cases where you get to use this, of course, even though it's not one of the things I use frequently myself. So I'm going to the do while loop now. So a do while loop simply executes before checking. It's more like talking before you think. Apologies. But it has its benefits. Maybe no matter what the condition is, you want to do something. Yeah, that's what it is. Do it, then check the condition. So what it means is execute this program, and I think this will end up in an infinite loop actually. So what I'm supposed to do is do an incremental here again. I would have just entered an infinite loop myself. Do while counter increment. Right. So that is what I'm doing right here. So it still does the same thing, of course, but it does the checking, it does the execution rather before checking. So that is what happens in that condition. So let's do. Bam, done. So it does the same thing, just that it executes before checking. So the major difference is between that and the while loop is the while loop checks before executing, the do while executes before checking. So another concept which might want to mess with your brain a little bit is recursion. Yeah, even though I'm not an expert in recursion, trust me. So I'll advise individual computers to worry about. The smart guys that wrote the operating systems should worry about that, and the compiler guys. Well, let's just focus on the code. So an example of where recursion happens is when we're trying to calculate the factorial of a number. You know factorial in mathematics, right? Let me drink, please. As I've been talking for close to how long now? I don't even know. But anyways, we go on. Oh, I've been talking for over 1 hour. Good. So I should run up pretty soon anyways. So what happens in recursion is a function keeps calling itself. Right, so you see I introduced the function here. Okay? And you'll see it has two references. The first reference is where it is called here. And the second reference is where it is called in itself. So if you mouse over this, actually, you can see, let me magnify that for you. So you can see it has two references. It's referenced where it is called and where it's called itself. So when you're calculating factorial, any factorial of 0 is 1, and it goes on and on. So the formula for factorial is you multiply the value in decrementing order till you reach 1. So that is what happens here. So a concept that comes to play here now is stack. But I don't want to go into the core details of that. Maybe it's what we'll deal with very deeply in some other videos, but I don't want to bore you too much about that. So stack is actually used here, but yeah, we'll deal with that later on. So what happens is I outputted this. Of course, I call the function here, but let's look at the function. If the 0 factorial is 1, so if the value is 0, just return 1 before you start doing some things you cannot get out of. So now if the value is not 1, it's not 0 rather, so that number multiplied by factorial of that number minus 1, then it goes ahead, reduces the value. Once it reaches, as long as that value is not 0, it goes on and on till it reaches that value, then starts popping it off, and then does the multiplication all through and returns the value. So let's go ahead and actually run this. So let's say we want to calculate 10 factorial, and then I'll do some breakpoint checking once I've verified that my system doesn't crash. So let me input 10. So that is the value of 10 factorial is 3,628,800. Right. So let's set some breakpoints and actually see what is going on. Right? So I think one breakpoint should be enough. Is it? No. Let's set 1 here instead. So let's run this. Let's do 5 factorial so we don't have to go through this 10 times. So let's do 5. So currently now, you see the value of n here? Value is 5. Then it goes ahead to execute, does all the checks. Then it comes back to the same point. It has decreased to 4. Then it comes back, becomes 3. Oh, sorry, you cannot see that. How do I do this again? So you see, down here, I've done some bad things to this PC. Yeah, so you can see 3 there. So it goes on and on and on to keep decrementing till it actually reaches 1. So it goes ahead. The value now is 2. Now it's 1. Then it becomes 0. Then it returns 1. Then the stack keeps popping, and then it outputs the value to the console. And that is what happens basically in recursion. So the factorial of 5 is 120. So let me zoom into that. Factorial of 5 is 120. Just in case you want to know the answer. So that is what happens in recursion. I hope I did not mess up with your brain in this. So luckily, guess what? This is the last section of this episode, and then we should talk about what we'll be doing next week. But before I go, let me make sure I push this code. Right. So I will just I love using VS Code also. So I'll just do I should turn my theme back to dark. Yeah, I should remember to do that. Like next time I'm putting this on, I'm getting a scare. So I'm just gonna git add, and I'm doing a git commit am. My system, you don't work. Okay, maybe I'll do this off screen. I don't know. Did I open something else here? Oh, I opened GitHub Desktop. I do not know how I clicked that. Pardon me. Oh, I guess I'll do this off screen, and I'll push the code But let's go. Okay, I'm here. Let me just push the code from here. Right. So in the next episode, come on, stop again. Okay, I can close the magnifier now. That is too low. So I want to make sure I actually push before I stop all this, so I do not forget. Pardon me, my PC is unplugged. Just a moment. Okay, we're back in power. So the next episode, guess what we're talking about? Well, I mentioned it. You kind of saw it. It's object-oriented programming. Yap. Object-oriented programming is what we're talking about next on this channel. Smooth Dev Saturday, is it? It is. Is it? It is. Yeah, Smooth Dev Saturday next episode. Oh. Make it a day with us, excuse me. Make it a day with me. I'll be talking object-oriented programming, stuff like inheritance, polymorphism, all those very cool concepts, and I'll be showing lots of more demos next week, next episode. So I'd like you to subscribe on YouTube, Twitch, Periscope, whichever channel you're watching this from, to make sure you get updates from me as soon as I go live. Follow me on Twitter if you're on Twitter. Follow me on Instagram if you're on Instagram is not yet because, of course, I can't live stream on Instagram yet. Yeah, but yeah, that's all of it. If you want to, so I'll write a blog post after this, of course. You can check me out at daroladapo.com. My Twitter handle is daroladapo, and you can follow me on any of these channels that you're on. So yeah, thanks very much for watching. Before I go, let me see if I can actually do some push. I may be able to. No, Visual Studio is still doing its stuff. Okay, but okay, changes. Some other time, I think when we get to DevOps stuff, we'll do some of this Visual Studio Online, Git stuff. So I'll call this demo wrap up. Then I'll commit these and synchronize to GitHub. So you can check the repository out now. You will see that once I refresh this page, all the code samples will be up and running, and you see this was updated few seconds ago. I think it's still doing the push from Visual Studio. It's still doing the stuff. Visual Studio is still studializing it. So yeah, if you want to turn off now, yeah, you can. I just want to make sure everything is set before I leave here. I would set my Visual Studio back to what it used to be in work mode. Next week again, I'll turn it back to live theme. So, yep. And of course, you have an automated way where I can set to light when I'm doing demos and when I'm working. Please let me know. I'll really, really love that information. Yep. So I'm back to that theme. Package manager console is where it's supposed to be. Everything is set and ready. So yeah, thank you for watching this episode of Smooth Dev Saturday. I will catch you on the next episode. I really want to say thank you once again. Make it a day with me next week. I am out.